Today we're going to finish up our discussion from yesterday of lesson 78 where we were talking about how to correctly solve our quadratic equations. Remember in our lesson yesterday we were focused on factoring. What did it mean to factor? What were the steps that we followed? Number one, you had to make sure your equation was equal to 0. So either you could look for a common factor first or you could break it down into two separate parentheses. When you're factoring, you're writing it as a multiplication question that is equal to 0. What does that mean then? One of those factors has to be set equal to 0. They have to equal 0 based on our zero product property, and that was the property that was used to help us come up with our final answer. The factoring method that we focused on yesterday was called the difference of two squares. We'll see this method show up in both of the examples that we'll walk through together today as well, along with a second method. So what was that difference of two squares? It was a squared minus b squared was equal to a plus b times a minus b. Because we had the minus at the end of our question, we knew that our parentheses had 1 plus and 1 minus. The first blank of both of those parentheses came from the first term with what did I square. The second blank came from the second term with what did we square to get to that second term inside of our parenthesis. I would like to start with one more example today of our factoring using our difference of squares, and this one is going to start off with an x to the fourth question. Yesterday, we started off with an x squared. We had an x cubed that was in our question. So now let's extend this process to an x to the fourth kind of example. So we have x to the fourth is equal to 625. Regardless of the kind of exponent that you have, the first step in factoring is to set your equation equal to 0. So I'm going to subtract over my 625. So I have x to the fourth minus 625 is equal to 0. Now the two terms that we have here, x to the fourth and 625, do not have anything in common. So I can't pull out a common factor, but I can break this down into two separate parentheses. Let's begin with x to the fourth. What can I square to get to x to the fourth? What do I use twice? It is x squared. X squared squared. Remember, we had multiple exponents. You multiplied them together. So x squared squared is x to the fourth. What do I square to get to a 625? It is 25. 25 squared is 625. So in the first blank of both of our parentheses, I put x squared that came from the first term. In the second blank of both of our parentheses, I put 25 because that came from the second term, and our equation is still equal to 0. Now, notice that at this point of the question, this is where we're going different than yesterday's examples. The second parenthesis that we have is the difference of squares. So I need to use the difference of squares format again. Notice the first parenthesis is not that situation because the first parenthesis has a plus. We don't factor something if there's just two terms with a plus in the middle if you do have that square. But the second parenthesis where it does have that x squared minus 25, that is an example where we have the difference and those are two perfect squares. Because what can I square to get x squared? It is x. And what do I square to get to 25? It is the number 5. So what I did, I left the first parenthesis alone because it's the plus sign. I cannot further factor that. And I broke the second parenthesis into two separate parentheses using our difference of squares. Notice the two parentheses that I now have it broken down into also have the plus and the minus sign because of the difference of squares format. The first term, what did I square to get x squared? It was x, so that went into the first blank of both of my new parentheses. What did I square to come up with a 25? It was 5, and that went into the second blank of both of our parentheses. Our equation still equals 0, and we have factored all that we can at this point. Now we can apply our zero product property to help us solve. We have three different factors, just like we saw yesterday in our question. The first factor is the x squared plus 25. The second factor is the x plus 5, and the third factor is the x minus 5. Any of those factors could be where the 0 is sitting, so I have three different equations that I need to write. So x squared plus 25 is equal to 0, x plus 5 is equal to 0, and then x minus 5 is equal to 0. Let's go back to the first equation. How would I begin to get x by itself? I would subtract 25. So I have x squared equals negative 25. On the second equation, to get x by itself, we just have to subtract 5. So 0 minus 5 is negative 5. And that answer is already done because the x is completely by itself. Same process on that third equation. To get x by itself, we would add 5. So 0 plus 5 is 5. And that last answer is also done because the x is all by itself. We need to go back and focus on that first equation, however, because x is not all by itself. What do I need to do to get rid of the square that is on my x? What's the opposite of a square? It is to square root. Well, notice what I would have in the question here. Let me get my pen turned on so I can show you guys here. If I were to take the square root of both sides of my equation, because that's what's necessary in order to cancel out a square, what I have inside that square root is a negative number. Well, we learned about that earlier this year. What do I do with a negative number underneath a square root? That was our letter I, our imaginary number. So that negative sign is going to turn to I. And then what's the square root of 25? It is 5. Now, don't forget this one. Another thing that we learned during our method when we did the square root of both sides, you had to include a plus and a minus sign. So x was equal to plus or minus 5i. Why did we have to put that plus or minus sign? Well, let's just say it was positive 25, not negative 25. So it said x squared equals positive 25. Well, if I use the same method and I square rooted on both sides of the question, well, what can I square to come up with a 25? You can either square 5 or negative 5. That's why we need that plus or minus sign when we insert the square root on both sides of the question. Notice how many total answers do we have. The first equation gave us 2 answers, positive 5i and negative 5i. The second equation, there's our third answer of negative 5. And then the third equation gave us the fourth answer of positive 5. Why are there 4 answers? Because the highest exponent that we had in the question was 4. So we've seen so far how we can correctly apply our difference of squares into our second, third, and fourth degree equations to continue to solve for x. Now, before we get to this last example where we're also going to apply the difference of squares, there's another kind of factoring that's going to show up on this question, and it's called a perfect square trinomial. What does it mean that you have a trinomial? There's 3 different terms, and specifically, what does it mean that it's a perfect square trinomial? Well, there's 2 characteristics. In a perfect square trinomial, the first and the last pieces had to be perfect squares. Whatever the first thing in the question, there has to be something I can square to get that. The last piece that's in the question, there also has to be something that I can square to get to that last term. Now, because I'm squaring something to get to the last term, that means the sign in front of the last term is going to be a plus in our question. That's also a characteristic of a perfect square trinomial. The last term is always a positive. Now, what about the middle term? Because there's 3 terms when I have a trinomial. The middle term was 2 times the root of the first times the root of the last. What am I referring to by the root of the first and the root of the last? It's what did I square to get to those pieces? And I have 2 examples that I'll show you here on the next slide, just about this perfect square trinomial before we try to tie it into our entire process that we've been working on here in lesson 78. So if I gave you the question, x squared plus 10x plus 25. Notice we do have 3 different terms, so it is at least a trinomial, and the last term is a plus. That's also something, as I mentioned, you have to have on a perfect square trinomial. Well, what are the qualifications? The first and the last terms had to be perfect squares. What do I square to get to an x squared? It was an x. So the first term is a perfect square. The last term, what do I square to get to a 25? It is the number 5. So my first and last terms are perfect squares. Here's how I check the middle term. It said the middle term was 2 times the root of the first, and that's what did I square, times the root of the last. Again, what did I square? Well, 2 times x is 2x, and 2x times 5 is 10x. And that's what I have for the middle term of the question. How did this perfect square trinomial factor? It was 1 parenthesis that had a square because the 2 parentheses would be identical in the question. Notice the first blank came from the first term. What did I square? It was an x. The last term came from the last blank came from the last term. What did I square? It was the number 5. How did I know what kind of sign to put in the middle? it was the same as the middle term inside of our parentheses. Now, yes, that could factor into two parentheses side by side because the plus at the end tells me the signs would be the same. The plus in the middle tells me what those signs are. So they would both be positive signs inside of our parentheses. The first blank of both of those parentheses would be x because x times x is x squared. The last blank of both of those parentheses would be 5 because 5 times 5 is 25 and 5 plus 5 is 10. So because those two parentheses are the same, that's why we can write it as that x plus 5 squared. Let me just walk through one other example with you so we can correctly do this on our last problem. Here, 9x squared minus 12x plus 4. We have a trinomial. There's 3 different terms, and the last sign again is a plus. Look at the first term. What do I square to get to a 9x squared? Well, that would be a 3x. So the first term is a perfect square. Look at the last term. It is a 4. What do I square to get to the number 4? It is a 2. So my first and last terms are perfect squares, so far so good. The middle term has to be 2 times both of those pieces that I squared. Well, 2 times 3x is 6x, and 6x times our 2 is 12x. So the middle term does meet the requirements of our perfect square trinomial. How would that question factor 3x minus 2 squared? The 3x came from the first term because that's what I squared. The 2 came from the last term because that's what I squared for the last term. This time there's a minus in the middle because we have a minus on that middle term of our question. So let's see if we can correctly take this idea of our perfect square trinomial and finish out with this last solving question. Now, yes, I know that's the longest question we've faced so far with our solving, but we know all of the steps that are necessary to help us come up with our final answer. So inside of the first parenthesis, and please make sure you write them in parentheses just like I have this problem. We have 25x squared minus 20x plus 4. Then our minus sign. Inside the second parenthesis is 16x squared plus 8x plus 1 is equal to 0. Now, your question on letter F is going to be set up the same as well with these two parentheses. The parentheses are there for a purpose. They want you to leave those pieces inside of the parenthesis to work with each one individually. Notice both of those parentheses are examples of a perfect square trinomial, so let's begin with that kind of factoring process. Over here in this first parenthesis, what do I square to get to 25x squared? It is a 5x. On the last term, I have a 4. What do I square to get to the number 4? It is a 2. The middle term is 2 times my 5x, which is 10x, times the 2 at the end, which is 20x. So the first parenthesis is an example of a perfect square trinomial. Same thing on the second parenthesis. What do I square to get to 16x squared? It is a 4x. On the last term, what do I square to get to the number 1? It is 1. The middle term is 2 times 4x, which is 8x, times 1 still gives me 8x. So how would my first parenthesis factor then? It's going to be 5x minus 2 squared. Why is it a minus? Because that middle sign goes into the middle sign of your parenthesis. The minus that was in between the parentheses stays as the minus sign in between the two parentheses. Here's your second factor for your perfect square trinomial, 4x plus 1. The 4x and the 1 were the two pieces that we determined that we squared to get to the first and last terms of the original problem, and the middle sign is a plus because the middle sign of the original question was a plus and your problem is equal to 0. So we've correctly applied our perfect square trinomial factors that we just talked through. Well, notice what this question is now. It's a difference, and you have two perfect squares. Both of those parentheses are being squared, so we can apply our difference of squares format. Okay, so here we go. Watch carefully. Inside, and I changed these to brackets. That way I don't have too many parentheses side by side. The difference of squares format has 1 plus and 1 minus, and I see that inside of my brackets. What did the difference of squares format do that we talked about yesterday, or even in our first example today? The first blank in both of the parentheses is what did I square for the first term? What do I square to get a 5x minus 2 squared? I squared a 5x minus 2. So that's the first blank of both of our parentheses. The second blank came from the second term. What do I square to get 4x plus 1 squared? I squared a 4x plus 1. So notice this first parenthesis went into the first blank of both of my problems, and then the second parenthesis went into the second blank of both of the brackets that we have on the question. Now that we have done all of the factoring possible with our perfect square trinomial first, then the difference of squares first, now I want to go ahead and combine the like terms together so I can continue to use my zero product property. In the first bracket, we have a 5x and a 4x, which make a 9x. We also have two constants, a -2 and a +1, which is a -1. So I turn them back into parentheses because I don't have individual parentheses inside the question anymore. Now, the second part of the question we've got to be a little bit more careful of because of this minus sign. This minus sign applies to both things that are inside of that second parenthesis. So 5x minus 4x is 1x, or just an x. And then -2 minus a 1 is -3. Again, I had two parentheses individually, but I put them together now, so I just have one parenthesis, so I could just switch back to my parenthesis marks in our question. At this point, we have our two factors, the question equal to 0. One of those factors has to be equal to 0, as we've seen on every other example in this lesson. So I have 9x minus 1 equals 0, or I have x minus 3 equals 0. The first equation, I added 1. The second equation, I added 3. The second equation is done because I have the x all by itself. The first equation, I'm going to divide by 9, so x is equal to 1 over 9. Notice there's two answers on this question, and that makes sense because the highest exponent I had in my question is our x squared. So we saw today, we started off with a question that was an x to the 4th. We broke it down with our difference of squares, but we had another difference of squares, so we had to continue to go in our question. And then the last example with our perfect square trinomial. A perfect square trinomial breaks into that one parenthesis that is being squared, and then we saw the example of our difference of squares even within our question. If you're struggling on how to factor these kind of questions, let me know, and I'll be more than happy to try to help you on your questions.